Question 5.3 asks us to use the data in Table 3 and our knowledge of the immune response to suggest why HIV controllers do not develop symptoms. So the first thing we need to do is look at the data and use it. So we can state from our table that the HIV controllers have a much lower viral load than the HIV positive patients, and they have a much higher number of CD4 cells, which are the T helper cells. So therefore we're going to use this data in our answer. We're then going to use our knowledge of the immune system to then describe why it is that having more of those helper T cells or a lower viral load is going to have an effect. So if we think back to our topic to do with disease and immunity, we learned that we have a non-specific immune response, which is when if a foreign antigen is detected in our body, the first line of defense is the phagocytes. They're going to engulf that pathogen. They will then enclose it within a vesicle. The lysosomes will then bind with the vesicle and empty their contents, which will then contain hydrolytic enzymes, which will then digest the pathogen. It could then present the antigen on its surface when we start to get to our specific response. So once the antigen is presented on the surface of the antigen presenting cell, a specific T cell that has a complementary receptor to the antigen could bind and become activated and then divide by mitosis to make lots of copies of itself, so that all of the cells have a complementary receptor to the antigen. Those T cells could then become memory cells in case you are exposed again, or they could become helper T cells. Those helper T cells could become cytotoxic T cells, which then go and kill the virus-infected cells of your own body by releasing the perforins. So the cellular response is all to do with killing the actual infected cells in your body. The helper T cells can also activate the B cells. So the specific B cell that has a complementary receptor to the antigen could get activated by the specific helper T cell. That B cell will rapidly divide by mitosis. Clonal selection will happen, where it makes lots and lots of copies of itself. They can then become plasma cells. The role of a plasma cell is to produce and release antibodies. These antibodies will be complementary to the antigen, so they can form an antibody-antigen complex. Therefore, they can clump them all together, so a phagocyte can then come along and engulf them very easily. They can also form memory cells in case there is a second response. So in terms of our mark scheme, the first 2 points are for using the data in the table, so the idea that there are more T helper or CD4 cells, or there's a higher proportion of the T helper to the virus particles, or the idea that there's a lower viral load. This must be comparative, it must be lower viral load that is infecting or destroying those T helper cells. Then our knowledge of the immune system then starts to be explained. So therefore the B cells will be activated, or the cytotoxic T cells or the phagocytes will be activated. The B cells will produce plasma cells, which will then produce antibodies, or the cytotoxic T cells will have the ability to kill the virus-infected cells. Therefore, they're more able to destroy any other microbe or pathogens, or they're more able to destroy any mutated cells or cancer cells. We're ignoring reference to the B cells acting as phagocytes or antigen presenting cells. The B cells will be activated in order for the plasma cells to be able to create the antibodies, which are complementary. If you are still confused about the immune system, there is a good video on Moodle called Cold Wars.